Gravity is one of the most noticeable things that anything that exists on Earth can experience. It keeps you firmly glued to the ground, and if you jump, it doesn't take long for gravity to pull you back down. On Earth, gravity is just right, as it allows us to keep ourselves in good shape while still allowing us to move around and do human things. But what happens if you crank gravity up by an absurd amount, like as much as you possibly can? Well, that's when you end up with black holes, which are about as close to a cosmic prison as you can get. Now, before we get into these strange things, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so what exactly is a black hole? Well, if you boil it down all the way, they're things with a gravity so immense, not even light can escape them. Contrary to how they're named, they're not really holes, but rather a region of space that light can't escape. At their center lies something known as a singularity, which is an infinitesimally small point that has the mass of multiple stars crammed into it. There are two main types of black holes: stellar mass black holes and supermassive black holes. Stellar mass black holes are black holes with mass of a few times that of the Sun, and they are scattered all over the galaxy. This is because they form when very massive stars collapse and go supernova, and while some of their mass gets ejected into outer space, a very significant portion of it gets packed so tightly that it's able to become a black hole. The second type of black hole, supermassive black holes, are a little bit more mysterious as we don't exactly know how they formed. While stellar mass black holes are a few times the mass of our Sun, supermassive black holes are millions to billions of times the mass of the Sun. This, in turn, means that these black holes are a lot bigger. While stellar mass black holes are no wider than a typical city on Earth, supermassive black holes can often dwarf the solar system many times over. These black holes are expectedly much rarer, only being found in the centers of large galaxies like the Milky Way. The reason why we don't know how they formed is because, based on how black holes gain mass, there shouldn't be a way for a stellar mass black hole to grow to the size of a supermassive one all on its own, and no other way of forming a large black hole is known at this time. Our best theory is that in the early universe, stars were much more massive than they are now, so they produced bigger black holes when they died. These black holes then coalesced into larger black holes, which in turn kept merging until they become the behemoths they are now. And one more thing to note. There is actually a pretty significant gap in black hole size between about 100 and 100,000 times the mass of the Sun. A few of these so-called intermediate mass black holes do exist, mainly in the centers of large clusters of stars, but they aren't as common as you would expect. Again, the theory is that the intermediate mass black holes that did exist merged into supermassive ones in the early universe, but this is just an educated guess. Okay, so now that we know what a black hole is, what happens if you get too close to one? Well, the short answer is it would not be pleasant at all. When you're pretty far away from the black hole, the only thing you'd notice is that you'd be accelerating faster and faster as you get closer to it, much like how gravity works on pretty much any celestial object. However, as you get closer, you would start to experience tidal forces. Tidal forces are essentially what happens to an object as it is being pulled on by another object's gravity. The tides in the Earth's ocean are the best example of this, as they are caused by the gravity of both the moon and the sun pulling on Earth's oceans. Since the moon and sun are so far away, the only major effects are the oceans rising and lowering a few feet or meters each day, which can cause some flooding in low-lying coastal areas. However, a black hole's gravity is significantly stronger than even the sun's gravity, and once you get really close to it, the tidal forces become extremely amplified. This kickstarts a process known as spaghettification, which is exactly what it sounds like. The black hole's gravity stretching your entire body downwards, which makes you decompress and lengthen until you are but a stream of atoms, which does not seem like a very fun experience. This isn't just the case if a human falls into a black hole. In fact, this happens to any object that ventures too close to one, even massive stars. What will happen to these stars is that their plasma will get stretched around the black hole, eventually becoming an extremely hot and fast spinning ring of matter known as an accretion disk, which will in turn slowly fall into the black hole and increase its mass. But what would happen if, against all odds, you survived the plunge into a black hole? What would you find inside? Well, to be 100% honest, we have absolutely no idea. The main theory is that at the center of the black hole, there's an object with no size and infinite density known as the singularity, which is responsible for the black hole's extreme gravity. But there are a few issues with this assumption, mainly the fact that something with infinite density but no size just doesn't really seem possible. There are a number of theories that aim to circumvent this problem, but none of them has conclusively proven anything yet. Of these theories, perhaps the single most insane out of all of them is the theory that black holes are a portal of sorts. There is a theory that a portal to some other part of the universe, scientifically known as a wormhole, could be possible due to the nature of space-time itself. Think of a piece of paper being folded in half. Sure, you could go all the way around the crease to get to the same spot on the other side, but wouldn't it be much faster if you could punch a hole through the paper so you could get to that corresponding spot instantly? That's the premise behind a wormhole. Black holes are a possible way to enter one, as their extreme gravity could depress space-time enough that it could punch its way to another region of it. If such thing was possible, you would most likely exit through what's known as a white hole, which would repel matter extremely strongly as opposed to attracting it. However, no evidence of these white holes have been found, and even if they do exist, and black holes are gateways to some distant part of the universe, the aforementioned spaghettification would prevent anything large from staying intact during the journey, barring some extremely futuristic device that can somehow negate the effects of tidal forces as a whole. Not to mention that we currently have no way of actually reaching a black hole that would be big enough. The nearest one to Earth is hundreds of light years away, and the fastest probes that humanity has produced are only 0.01% the speed of light at best. So until then, we are sadly confined to the incredible methods of transportation that we already have, which are capable of going anywhere on Earth in just a few hours, something that would have been unthinkable just a few centuries ago. Gotta run what you got. And that's all I have to say on black holes. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.